Imagine being handed a drawing of a 62-story skyscraper and being told the skeleton doesn't go inside the building. It wraps around the outside. It curves. It twists. It flares out at the base like a tail preparing to strike. Engineers looked at this drawing and asked the obvious question: how do you even build that? And here's the strange part. Designing it wasn't the hardest problem. Building it, physically, floor by floor, was. This is 1000 Museum. Locals call it the Scorpion Tower. It rises 62 stories over Biscayne Bay. And it was the final skyscraper designed by Zaha Hadid, the architect they called the Queen of the Curve. Hadid never designed straight lines when a curve would do. But this building wasn't just curved for style. Every sweeping line on its surface is structural. It's holding the building up. Most skyscrapers hide their skeleton behind glass. This one puts it on display. A continuous, sculpted concrete frame wrapping all four sides of the tower, from the ground to the sky. It looks like something alive. And before a single floor could rise, the building had a much bigger fight on its hands. The tower hadn't risen an inch yet, and already it was fighting the ground beneath it. Miami sits on porous limestone, close to sea level, with a water table just below the surface. You can't simply dig a hole and pour a foundation here. The ground won't hold it, so engineers went down instead of building up. More than 200 concrete piles, some over 160 feet deep, were driven into the earth, anchoring the tower to bedrock far below. Above them, a matte foundation over 10 feet thick spreads the entire weight of the skyscraper evenly across the site. There was one more complication. Another 48-story tower stood just inches from the property line. Every pile had to be placed with almost no room for error, because if this foundation shifted, it could take its neighbor down with it. Only once the ground was secured could the real challenge begin. Here's the problem nobody could ignore. A normal skyscraper skeleton is made of straight steel columns, poured inside straight concrete walls. This building's columns don't run straight. They lean, they twist, they widen and taper as they climb, spreading out like roots at the base to grip the wind. Standard construction formwork, the temporary molds that hold wet concrete in shape, is built for flat walls and right angles. It cannot bend into a flowing organic curve, not without an enormous amount of custom labor for every single floor, on every single column. And this exoskeleton wasn't decoration. Structural engineers had actually used the curved frame to replace the building's thick internal shear walls, the load-bearing walls that normally run through a tower's core. By pushing that structural work to the outside of the building, they freed up the interior completely. No columns blocking the view. Open, column-free rooms up to 45 feet across. But that decision came with a price. The exterior frame now had to carry the entire building's weight, and Miami's hurricane winds on its own. So the shape wasn't just difficult, it was mission critical. Every curve had to be exact, structurally exact, not just visually exact. The team needed a way to build a mold for a shape that had never really been built before, one that could survive a hurricane, and one that wouldn't take a decade to construct. The solution came from an unexpected place, a material better known for decorative panels and lightweight cladding, GFRC, glass fiber reinforced concrete. It's a thin, incredibly strong composite. Cement reinforced with woven glass fibers instead of heavy steel rebar. Because it's so light, it can be cast into almost any shape, including deep, sculpted curves that regular concrete formwork could never hold. Normally, GFRC is used the way you'd use a decorative tile, bolted onto a finished building as a skin. Here, the team used it differently. They precast thousands of individual GFRC shells, each one a small, exact piece of the tower's curve. These shells weren't decoration. They became permanent formwork, hollow molds that stayed on the building forever.
Keep the complicated. She is commenting.
Workers assembled the shells directly onto the rising structure. Steel reinforcement went in through the middle. Then structural concrete was pumped inside, filling the GFRC shell from within, turning it into a single solid, load-bearing column. The GFRC wasn't just holding the shape while it dried. It became part of the finished skeleton, sealed under a smooth outer surface. One pour, one process, one curve, locked in forever. It was the only way to turn Zaha Hadid's freehand sketches into something a 62-story tower could actually stand on. Here's what most people never realize about this tower. It wasn't only built in Miami. Nearly 5,000 individual GFRC pieces were engineered and manufactured almost 7,000 miles away, in Dubai, then shipped across the Atlantic to Biscayne Boulevard. Every panel was different. Every curve on this building is unique, which meant every mold, every shell, every piece had to be custom designed before it ever left the factory. Then it had to arrive in Miami and fit, not roughly, but precisely into a structure rising in real time, thousands of miles from where it was built. It became one of the largest three-dimensional puzzles in modern skyscraper construction. Get one piece wrong, and an entire section of the exoskeleton wouldn't align. Then, in September 2017, the building faced a threat no formwork could solve: Hurricane Irma. A Category 4 storm, bearing down on South Florida, with the tower still under construction, unfinished, exposed, its cranes still standing high above the skyline. Across the city, construction crews raced to secure their sites. There wasn't time to fully dismantle the cranes. Taking one down could take 2 weeks, and the storm was already days away. The site was locked down. Loose materials were tied off or removed, and then there was nothing left to do but wait for the storm to make landfall. Irma hit Miami on September 10th, 2017. When the winds finally passed, the tower was still standing. The site had held. Construction resumed. The race upward continued. Somewhere in this story is a much quieter one. Zaha Hadid had visited the Miami site while the building was still in its earliest stages, watching her design begin to take physical shape for the first time. Then, on March 31st, 2016, Zaha Hadid died suddenly, at 65 years old. The building she designed was still rising when she was gone. That left her team with a question no engineering formula could answer. How do you finish a building when the person who imagined it is no longer there to guide it? The answer was to hold the line. Zaha Hadid Architects, together with the local architects and engineers, continued the project exactly as she had envisioned it, protecting every curve, every proportion, every detail that made the design hers. The tower kept rising, not as someone else's building, as her building finished by the people who understood it best. Today, 1,000 Museum stands complete over Biscayne Bay. 62 stories, a curved exoskeleton unlike anything else on the Miami skyline. 84 residences behind a frame built from thousands of custom-shaped panels, cast on 2 continents, assembled around a foundation driven more than 160 feet into the earth. At the beginning, the question was simple. Can something this strange actually be built? The answer took years, 2 countries, a hurricane, and the loss of the woman who imagined it. But it was built, and it's still standing. Proof that the gap between an impossible sketch and a real skyscraper isn't imagination. It's engineering.